The final 1 week from today. Yeah. 1 week from today. Yeah. So let me just write something here regarding the final. Yeah. Yeah, so final exam, yeah, again, December 18th, Thursday, 10 a.m., 12 noon. Yeah, here in classroom. All right, yeah. So that's the part B. All right, yeah. This is the part B. 15 computation questions. All right, yeah. In 15, last 3 challenging questions. All right, yeah, last 3. Challenging. Okay, all right. First 12 basic questions. All right. Then part A, concept, online. Online quiz format. All right, yeah. Given after part B, all right? Right after B. Start 12 noon. All right, yeah. Right after part B. Part A. And Saturday. Yeah. 19th, 20th. End of day. Part A, okay? Yeah. 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 The same as quiz 6, right? Yeah, as I mentioned. Yeah. Yeah. It's quiz 6. Yeah. Yeah. All right. Then the question. Yeah, I also want to talk about 10 questions in part A. 10 questions. Yeah. Concept questions. 5 from Module 5. From Module 5. Module 5 because we only have part A, right? Yeah, only part A. 5 from Module 4. That's part A. Okay? Yeah. All right. Yeah. All right. Yeah. First, let me talk about quiz 5. Yeah. I only want to explain 3 questions. I already opened up the answers. Yeah. So you can, check which question you missed. Yeah. But I made some corrections. Yeah. For some students, yeah, the answers, for example, 5 comparisons. If the answer, fill in the blank type, 5 comparisons, but several students also enter this comparison, then the grading tool, because my answer is 5, okay? Yeah, I didn't enter comparison. Then the grading tool, treated as a wrong answer. Then I gave all the points back, okay? Yeah, so I went through one by one, Whenever I saw this kind of mistakes, so I correct it. Yeah. So, all right. Yeah. That's the. So in the final, if you only enter number, okay. When you do the filling the blank, that type of questions, you only enter number. Do not enter any word. Yeah. Do not enter any word. Yeah. Yeah, because I saw 3 or 4 students in your class, 3 or 4 students. Yeah. So it's quite common. Yeah. All right. So that's the, Yeah, the first question. Question number 2, answer is 3. Yeah. Because so many students give me 7. Yeah. The reason, when you give me 7, you use the linear insertion, right? One by one. Okay. Yeah. But here I already give you you do not have to use the standard insertion operation. You can use the binary insertion. Binary insertion. Yeah. Because 7 elements, 7 elements, when you do binary insertion, first comparison. Okay, all right. Then, second comparison. Okay, all right. Then third comparison. The binary type insertion. Yeah. So I give you some hint. Yeah. So that's the first question. Second question, in class, I emphasized the formula, exact formula for the worst case. 2 versions. First version, ceiling function. Second version, floor function. Okay, all right. So the answer is 8. But so many students just take the log base 2 of this number, power of 2. So many students give me 7. Yeah. Because this is 7, but you need to plus 1, get 8. Okay? Yeah. I estimate more than 50% of our class missed. More than 50% give me 7. Yeah. So common. Okay? Yeah. In class, I emphasized many times. Yeah. And I spent a lot of time explaining how to derive these 2 formulas. Yeah. Still, 50% missed this question. Okay? Yeah. All right. Number 10. Also, quite some students. Yeah. I estimate 4 or 5 students missed this one. It's false. Yeah, let me explain why. This is our lower bound formula, right? Yeah. In class, I gave you the lower bound formula. Lower bound formula. What kind of lower bound? For comparison-based algorithms. Comparison algorithm. Because there are some non-comparison algorithms. We do not use comparison operation to sort. There is a special sort called counting sort. We do the counting, we count. Yeah. But that algorithm is very special. Yeah. All right. For comparison sorts. Yeah, here we do the sorts, comparison sorts. No. Okay. This is the lower bound. No. All right. But the question here is, if the lower bound, because if you achieve this lower bound, it must be optimal. But the question I ask you here is, can you always achieve the lower bound? Because if you achieve, it must be optimal. But we don't know if we can always find an algorithm to give us lower bound, the number given by this lower bound formula comparisons. Nobody knows that. Nobody knows that, right? Yeah. So here, when we select true, it must be 100% true, right? 100% true. And you can prove it. Or someone can prove it. Yeah. Not necessarily you. Yeah. Okay? At least one person in the world can prove it. Then we treat it, it's true. It's a true statement. 100%. But now nobody can prove it. Okay? Yeah. Nobody can prove it. How can we say it is true? Nobody can prove. Probably in future. So this one, it's possible. Probably after 500 years, someone can prove it. That's possible. That's possible. But we cannot say 100% true, right? Yeah. Probably people can say 90% true, but still not 100% true. Yeah. So that's why this statement, we treated it, at this point, we treated it false. Yeah. We don't want to take that 10% risk, because there is a 10% risk. Yeah. We don't want to take that. Okay? Yeah. So that's the meaning of this question. In class, I mentioned, yeah, if we can achieve this lower bound, nobody knows that. Yeah, nobody knows that. Okay? Yeah. But my guess is, it's highly likely there is one example nobody can achieve the lower bound. Yeah, that's my guess. Yeah. Yeah. Lower bound there, but it can be proved nobody can use that many comparisons to sort it. That's my guess. Okay? Yeah, based on my intuition experience. Yeah. Yeah. May not be true. Yeah. I just make guess. Yeah. Okay? Oh. All right. Yeah, so that's the quiz 5. I select these 3 because these 3 were the highest missing rates. Yeah. Highest missing rates. These 3. Yeah. 30%, 40%, 50%. Yeah. Number 2, 30% missing rate. Number 10, 40% missing rate. Number 5, 50% missing rate. Yeah. All right. Yeah. Next, part B, computation questions. Yeah. All right. Yeah. So based on my grading, first, I just graded the first few students. Yeah. But I got some ideas. Yeah. Because I need to make comments. Yeah. I got some ideas. First thing is for this assignment, you did much better than homework assignment number 1. Yeah, significantly better. Yeah, based on what I saw. Yeah. I just predict. Yeah. For the first few, yeah, because all 4 students did better than the first one. So my prediction is, for the whole class, yeah. So you did better than the homework assignment number 1. Yeah, but I want to point out several common problems. Yeah. All right. First, you need to be very familiar our basic results before you do the final. So here, let me list those basic results. You have to be very familiar with those, because most of our questions are based on those basic results. Okay, all right. The first one, sorting, the basic sorting. Yeah. Three element, yeah, let me write just 3 array. 3 comparison, right? 4 element array, 5 comparison, and a 5 element array, 7 comparison. Yeah. These basic sorting results. So you have to be familiar with. Yeah, because we need to use them, here and there, many places. Yeah. So that's the first one. Second one. Finding the median. Yeah, median. Median of 3. Okay. Yeah. 3 array. Also 3. Okay. Also 3. Yeah. Median 5 array. 5 element array, all right? 6, yeah, these 2, enough. Okay. Yeah. Median, these 2, okay, yeah. And for the 3 case, we know, after 3, yeah, actually, basically, we sorted, right? So, you know the median here, and 1 above, 1 below, okay? Yeah, that's 3. For the 5 element median, you do not sort it. Yeah, so the diagram should be, so this is the median, but 2 above and 2 below. Okay, yeah. But we do not know the order between the 2 elements above, and we do not know the order between the 2 elements below. Okay? Yeah. So that's what we have after we find the median. Okay? Yeah. So we can use these basic results in our problem solving. Okay. All right. So that's the second one. Third, find the second largest or smallest. Find the second largest or smallest. In an array. The formula n plus yeah, this basic result. Yeah, yeah. A lot of places we need to use. Yeah. All right. Number 4. Merge operation. And a partial merge. Yeah. Also very useful. Yeah. So many places we need to use these two formulas. These two methods. Yeah. Methods. Yeah. Okay, yeah. All right, yeah. So that's pretty much the basic results we need to be very familiar with before we go to the final exam. Yeah. Okay, all right. Yeah. All right, then let me talk about also selected questions, the common errors in your homework assignment number 2B. Yeah. All right. Yeah. So I need to use different software to do it. Yeah. I select several important questions to explain. I do not need to go through every one question. I do not have enough time. I only have 40 minutes. Yeah. But I will post my solution. Yeah. Solution file. Yeah, so you will get everything. Yeah, but there are several important questions. So I need to use our precious 40 minutes to explain. Yeah, all right. Yeah, the first question apply the formula, so I do not need to talk about it. Yeah, actually, based on what I saw, nobody missed the first question. All right, but the second one, you did well. Yeah, you did well. Yeah, but I only want to say one thing. Yeah, here you can see what we have. Basically, we have two ordered arrays, right? Yeah, so we have two ordered arrays. Already, when we start, then can we apply standard merge operation? Yeah, so we can apply the merge operation directly. Then, because the merge operation, for the worst case, 2 plus 2 minus 1 equals 3, right? Yeah. So easy. All right. If you use the merge operation, very easy. Here, the point I want to make here is at several right situations, you need to connect to the merge operation and the partial merge operation. Yeah. Here, one situation you can connect to the merge operation. Because the setup is perfect for the merge operation. Yeah. Yeah. But most of you didn't connect. Yeah. Although what you did correct. Yeah. Yeah. But it takes more time, right? Yeah. If you can connect to the merge operation, you can get correct answer immediately. Save your time. In your final, you only have 2 hours, right? You want to save time. You want to save your time, only 2 hours for 15 questions. Yeah. Although the first 12 questions, not that hard. Yeah. The last 3 questions, a little harder, yeah, but you use your homework assignment, number 2B, yeah. Yeah. Because I will make similar questions, yeah. Not brand new questions, similar. All right, yeah, that's this one. Yeah. And number 3, no, yeah. Yeah. Number 4, number 5, yeah. So I want to say in this way. I want to, yeah, because I noticed some students messed up. Messed up. No. So what do I mean, messed up? Because in my hint, I use the notation. Yeah. So when we represent the comparison result, I use this notation. A vertical bar B, and A means the number of comparisons. Here, this notation for a merge result. Okay, when you do the merge, you need to write your merge result. Yeah, so we use this simple notation to write. A, the number of comparisons for this merge. All right. B, the data size after the merge. That's total number of elements. Okay, total number of elements. So the question is, several students, when they use, because sometimes we need to use A, sometimes we need to use B, but some students messed up. When we need to use A, they use B. When we need to use B, they use A. Okay, so here I want to clarify. When do we use A? When do we use B number? Okay, all right. Yeah. When use A number, B number. Yeah. All right. A, because it's the number of comparisons. Okay. So when we calculate the total number of comparisons, we use A. When we calculate the total number of comparisons, when we use B, when we apply the two merge formulas, best case, worst case. Best case, worst case, then you use B. Yeah. For several students, when they apply the merge formula, when they apply, they use A. Yeah. They messed up. They use A number. Okay? Messed up. All right? Yeah. And that's the common problem for, both questions. Yeah. Yeah. So in the final, you need to make sure. Okay? Yeah. So when you use the notation, A, B, yeah. Okay? Using the guideline here. This is the guideline. Okay? Yeah. How to use the formulas in the right way. Yeah. All right, so that's this question, these two questions. Yeah. Then the next one, so this one I skipped. Yeah, this one I skipped. Yeah. Actually, this one we can put in the same category, okay, included. Yeah. Because in this one, you also need to use this notation. Yeah. Then, all right. This one we use the basic formula, right? Yeah, because this one use that median of 5 formula. Yeah. So here you need to connect to the median of 5 quickly. Yeah. All right. And these two actually similar, right? Yeah. So I want to, put them together. Yeah. Because same category. Yeah. So the meaning the same. Yeah. So, all right. I want to explain the general approach. Yeah. For a question like this, our general approach. All right. Yeah. So we draw a diagram like this. Top 13, not in top 13. Okay. First, we need to represent the top 13 area. It is forbidden. Okay, that area forbidden because you cannot get into that area. Yeah. We do not want our location in that forbidden area. Okay? Yeah. So we need to leave it out. Okay. Yeah. Yeah. Top layer. Yeah. Not allowed. Okay? Yeah. So this place not allowed. All right? Yeah. All right. Then the bottom layer not allowed. Okay? Yeah. Not allowed. Right? So for this question, there are at least 13 elements in this top layer. Oh, yeah. All right? And 1 element in this bottom layer. Okay? All right. So then, our solution layer, this is our solution layer. Okay? Yeah. All right. All right? Yeah, solution layer. Yeah, so that's the room we have in this solution layer. Yeah. All right. To find a solution, we need to put at least 13 elements in top layer, put at least 1 element in the bottom layer. That solution layer, we need to have at least 1 element in the solution layer. So 13 top, 1 bottom, and 1 in the solution layer. At least 1. Okay? All right. So total, we need to consider 15. So that's how we set up. This is the setup. Okay. All right. Then the solution basically the second smallest. Yeah. So we can apply the second smallest formula. Okay? Yeah. So that's the, general idea. Yeah. All right. Okay? Yeah. All right. Yeah. That's this one. All right. Then, next 2 questions, I want to talk about these 2 questions together. Yeah. Number 9, number 10. Number 9, number 10. All right. I noticed some problem. Yeah. So in my hint, each one, I give you 3 cases. Yeah. Because here, you have 3 ordered arrays. Then, when you do the merge, you have 3 different ways to do the merge. Yeah. And we do not, so the question is, we do not know which of the 3 is the best. We do not have experience. Yeah. So when you have no experience, yeah, the question, we have no experience. If we have no experience, we need to try all 3 ways. We need to try all 3 ways. Then pick the best one. Okay, that's the idea. But a few students only did one way. Then give me the answer. If your way happens to be the best way, then you get full credit. But if your way is not the best, you get half of the point, 2 out of 4 points, because it's not best solution. Okay, yeah. All right, yeah. That's the problem. Yeah. So the same problem for both these questions. That is, before we have the experience. Now, after we complete the assignment, we should have some experience, right? Yeah. We can summarize our experience to make some valuable conclusions. Yeah. Here, I do that work for you, okay? Yeah. Because it may be hard for you to summarize the results. Yeah. All right. Here, I give you two right ways to solve these 2 types of questions. The correct way. Okay, so you can get the best solution directly, yeah, without going through all the cases, yeah, because people don't like to try all the cases. Yeah. If you have a better way, yeah, you should use the better way to do it. No, all right. So the way I want to introduce you is, remember I mentioned in class, the greedy algorithm. Greedy algorithm. All right? Yeah, the greedy algorithms. Yeah. Here, if we use the greedy algorithms, we can calculate our solution directly without doing experiments. We only work on one greedy case. That's the solution. One greedy case. Okay? All right. So here, let me review this greedy algorithms. Okay? Yeah. Because in the final, I will definitely give you at least one such question. Okay? Yeah. 1 or 2. Yeah. Both possible. Yeah. Yeah. Probably 2. Yeah. Yeah. All right. So regarding the greedy algorithms, we need to choose greedy strategy first. Yeah. Choose some greedy strategy. For each question. Okay? All right. So here, let me give you the greedy strategies for these 2 questions. 2 questions. Okay? All right. Here, the best case. The second one, worst case. Worst case. Yeah. Let me give you the greedy strategy for the worst case first. Yeah. Yeah, because this one more straightforward. So let me give you the greedy strategy here. All right. greedy strategy is, when you have a list of ordered arrays, because here we talk about the general problem, general question. We talk about, we have a list of ordered arrays. Okay, here I use array size A1, A2, AK. Okay, and I want to order these numbers in ascending order. Okay, because I need to use this order to apply my greedy strategy. Okay, in ascending order these numbers. Then the greedy strategy was every time when we do a merge op operation, we merge two subarrays with the smallest with the two smallest size numbers. Okay, that's our greedy strategy. Pick the two smallest size numbers. That's our greedy strategy. How do you define your greedy strategy? This is the way we define our greedy strategy. Here, all right, let me use this as an example. Here, three numbers, 8, 21, 37, 53. Okay, the first time we merge these two, because smallest size numbers. Okay, so what do we get? All right, m plus n minus 1, 58, 57, right? 57 vertical bar, and the size 8. Okay, all right. Then, after the merge, we need to order the remaining ordered arrays, 53 and 58. Because this time you need to use 58 there. Then you do the merge. 110 and 111, right? 110 and 111. Okay? Yeah. And some students just give me one number as the answer. But when you calculate the answer, you need to add up 57 plus 110. To calculate the total, add up. Calculate the total. Okay? All right. Yeah. So that's the greedy strategy. Okay? You only need to work on one case. That's enough. Yeah. All right. But the question here is, in the final, I may give you more than 3 numbers, more than 3 ordered arrays. Because after you know the greedy strategy, you don't worry about it. Okay? Yeah. Even if you have 5 ordered arrays, you apply greedy strategy. Okay? here, let me do a quick example. Yeah. Suppose we have 5 ordered arrays. Okay? Our problem size, 5, 7, 13, 16, 22. How about that? Okay? So when we start, we need to merge these 5 ordered arrays. Let us apply the greedy strategy. Okay? Every time we merge 2 ordered arrays with the smallest 2 size numbers. Smallest 2 size numbers. Okay? All right. M plus n minus 1, 12, 11, right? Yeah. So 11 comparison, the size is 12. But 12, we need to put it back, right? 12. Yeah, because you get 12 ordered arrays. You put it back. After you put it back, 12, 13, these 2 are the smallest problem sizes. So you will get another merge, 25, 24, 25. Okay? Then your 25, you need to put it back, right? Yeah, put it back. You have 3 numbers. Okay? Yeah. So your next merge between these 2 smallest numbers. Okay? Yeah. Yeah. So you have 38, 37, 38. Then you put a, so here, 25 here, 38 there, 38 there. So your last merge between those 2, 63, right? Yeah. So 62, 63. Okay? Yeah. Yeah. So you get all of them merged. All right? Then you calculate total. Total. The first one use 11. Yeah. Do not mess up. Do not use the wrong number. 11 plus the second one 24, right? Yeah. The second one 24. The third one 37. The last one 62. Okay? So that's the greedy strategy. Okay? Greedy strategy. For the worst case, now let me do the best case. Best case. We need to define a different greedy strategy for the best case. Okay, all right. Let me give you a different greedy strategy. Best case. Greedy strategy. Yeah. All right, this time, okay? Every time for a merge, we merge two subarrays with the critical part, okay, with mean size. You know the meaning, right? Minimum size, okay, and max size. The minimum size and the maximum size. When you do the merge, that's the definition of the greedy strategy. All right? Yeah. Okay. Yeah. So here, your first merge, mean size 17 is the mean size. Max size 41 is the max size. Okay. Yeah. Because the minimum, right? 17. Yeah. The maximum sum of the two numbers 58. So you get 58. You put a 58 back to the list, okay? Yeah, to the list, and to the remaining part. Yeah. Here, let me do a 5-element example to show you the details. All right. So merge 3, 6, 10, 15, 19. How about that? Okay. So let's merge for the best case. Okay. This time best case. All right. The first time. Yeah. So let me just write merge short. 3 and 19. Min size and a max size. All right? Yeah. So what do you get? 3, 22. Then, so 3 is gone, 19 is gone, but you need to add 22 back to the list. The next round, you merge min size, max size 22. All right? So you get 6 comparisons, the size 28. Okay, 28 size. Yeah. So 6 is gone, 22 is gone, but you need to add 28. Okay. Next merge 10 and 28, min size, max size. So you get 10 comparisons, 38. Right? Yeah. 10 is gone, 28 is gone. You write 38 back. So you have last 2 left. Okay? So your last merge, MG 15, min size, max size 38. So what you get? 15, 453. Right? Yeah. So then when you calculate the total, you add up all these comparison numbers. Yeah. All right? Yeah. So here, right? 3 plus 6 plus 10 plus 15. That's the best case. How you apply the greedy strategy for the best case. Try to understand these 2 questions. Because in the final, I will give you 1 question for the best case, 1 question for the worst case. Each one, you need to merge 5 ordered arrays. Okay? Try your best to understand the examples, strategies here. Then you don't need to do so many experiments. No need. Only do 1. Based on the greedy strategy. Okay? Yeah. All right. Yeah. Yeah. So let me continue. Yeah. The last few questions. Yeah. All right. Oh, number 12. I need to make important comment. Yeah. So many students made the same error. The biggest error here, yes. We calculate average case efficiency. When you calculate average case, no need to round your answer to an integer. So many students run the answer to, the answer is 76/19, and some students give a slightly different number. So many students round it to closest integer 4. Don't do it. Yeah. Because when you do average, so why those students want to make an integer because they feel the number of comparisons should be integer. But when you do average on integer numbers, you can get a non-integer average. Average is, if an average is not integer, that's normal, right? How can you make an average integer? Yeah. So it's normal. Average is a non-integer number. Yeah. When you do best case, worst case, you need to use integer numbers. But for average case, you do not need to use integer numbers. That's the biggest mistake. Yeah. The missing rate so high. Yeah. 80%, 90%, that high. Yeah, 80%, 90%, that high. Yeah. 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 When you see average, no rounding up, rounding down, no rounding. Yeah. Just give me the fraction, the final fraction. Give that fraction to me. Okay? Yeah. All right. Then, the last three questions. Yeah. All right. Yeah. Each one, I'll give you several questions. Yeah. So in my solution, several questions. Yeah. But so here in the final, yeah, because in the final your time is very limited. Yeah, very, very limited. Okay? Yeah. So usually it's very hard to find the best solution. Yeah. But you can think about weak solution. Weak solution just one more comparison than a strong solution. But for the weak solution, yeah, we have a powerful tool, partial merge. That's a powerful tool. Okay? You can apply partial merge easily. Yeah. All right. So for the median here, you split into two subarrays. Yeah. The first subarray, 4 elements. Second subarray, 3 elements. Although you have a different split. Yeah. In my solution file, I give you, all the other cases. Here, I only talk about one special case. Sort 4-element array, you need a 5 comparison, right? Sort 3-element, you need a 3 comparison. Then, to find the median, what's the median? Median, that's the 4th smallest or 4th largest, right? Yeah. So you apply partial merge. Yeah. Merge these two subarrays, but as soon as you get the 4th number, you stop immediately. That means 4 more, okay? Yeah. 4 more comparisons. Yeah. So 5 plus 3 plus 4 get 12. That's the weak solution. Weak solution. Strong solution 11. Yeah. But in the final, in a very short time, if you get a weak solution, it's pretty good, because you only lose 1 point. Total 4 points. You get 3. Good enough. Good enough. Okay. All right. Yeah. Last thing. Yeah. Of today's class, same strategy you can use in this last question. Very challenging. Yeah. 9 elements split. 5-element subarray, 4-element subarray. Okay? All right. Sort 5-element array, we need 7 comparisons. Sort 4-element array, we need 5 comparisons. Right? Yeah. So we, and the median, it is the 5th smallest or 5th largest, right? Yeah. We apply partial merge. So we need 5 comparisons. Then, for the weak solution, 7 plus 5 plus 5 equals 17. That's the weak solution. All right? That's the weak solution. And if you get a 3 out of 4 points, how good it is, right? Yeah. Because the strong solution, you need much, much more time. Okay? You may not have that much time in the final, all right? So in the final, yeah, just take the weak solution, all right? Take the weak solution. Yeah. All right? Yeah? All right, that's it. Yeah. So we go home and prepare for the final. So I will post the solution file tonight. Okay? Tonight I will post. Yeah. All right.